Okay, so this problem is really about the words and or as they used in mathematics. So we have these 10 numbers and we have to find all the numbers among these 10 that A and B. And notice that the two statements are identical, it's just a word in between them. This says and this says or. Part A says we're going to have to find all the numbers that are greater than or equal to 6 and that are odd. Let's say you're solving this problem first. So then we can test all the 10 numbers. It's just 10 numbers, not that many. So 1. If we put 1 into X, 1 is greater than or equal to 6 and 1 is odd. Is this a true statement or a false statement? Well, this statement here is false, right? 1 is not greater than or equal to 6, and this one is true. So the question now, what about the compound statement when one part is true, the other part is false, and they're put together by the word and? So if this word is and, that means that this statement, this compound statement, is only true if both of these are true. Well, that's not the case. 1 fails to be greater than 6, therefore 1 is not going to be in the solution. So 1 can be ruled out. And then we roll up and we're going to play this 9 more times until we tested all 10 numbers. 2 greater than or equal to 6 and 2 is odd. Well, that's even worse, right? Now we have 2 false statements. So we have false, false. So this one was false, false. Okay. Now eventually you're going to be able to skip ahead here because you will have a sort of an instinct about the words and or. But suppose this is new for us, so let's go over a few more. What about 3? That's false, and we don't even have to figure out whether the second one is true or false because that already renders the whole statement false, right? And then we can get a little slick about it and say, well, that's going to happen with 4 and with 5. And then we reach the number 6 where the first statement starts to be true. So 6 greater than or equal than 6 and 6 is odd. And from now on the first statement will be true, right? Because we're testing them in an increasing order. But 6 is not odd. So this is a false statement, and because of the word and in between them, that renders this compound statement false. So far we didn't find any number that would satisfy these conditions, not one of them. But now it's getting a little bit interesting because we have numbers that will work with the first statement. So for example, 7. Is 7 greater than or equal to 6 and being odd? That is our first statement, where both statements within the compound statement are true. And so 7 is a number that is on this list. 7 is greater than or equal to 6 and 7 is odd. What will happen when we roll up to 8? When we roll up to 8, this will fail. So the whole statement will be false. Then we roll up to 9. 9 will work again. 9 is odd and greater than 6. So 9 works, and then 10 again is not odd. So the answer for part A is 7 and 9. These are the only numbers that work. Okay, what about the other half when we have the word or? Now in case of or, just one truth is enough to make the entire statement true. If we start testing the numbers, if we substitute 1 into X, 1 is greater than or equal than 6, that's false. 1 is odd, that's true. But now, because this is or, this is not true for 1. So 1 is going to be on that list, right? 1 did not make it on the list because with and, it both had to work. With an or, just one is enough. Just one of the two statements is enough. And then what about 2? False, false. 2 is not on the list. 3 is not greater than or equal to 6, but it's odd, so we found 3. 4, false, false. 5, false, true. So we're picking up the odd numbers because of this part, right? Actually, we can sort of see down the road that every odd number will be found here. So 1, 3, 5, 7, 9 for sure. Let's roll up from 5 to 6. 6 is greater than or equal to 6, but not odd. But because now the first statement is true, 6 is on this list. And from now on, if you remember from the previous part, the first statement will be true for 7, 8, 9, and 10. So this is a much longer list. So when you demand that these two both of them must be true at the same time. Only 7 and 9 does that. 7 and 9 are big odd numbers. When you just demand big or odd, then you're sort of collecting all the big numbers and all the odd numbers. It is easier for a compound statement to be true if the word between the statements is an or. Thank you for watching.